Yeah. I totally stole that from. There's like a site like Are We Web Yet or something like that. There's another one. Are We Async Yet?
Yeah, there's so many for Rust. It's like Are We GUI Yet? Are We Games Programming? Whatever.
Did the same guy make them or something?
Huh?
Did the same person make them, or is it just like a community meeting?
I think it started from the web. I think it started with Are We Web Yet, and then I think other people just copied it.
Yeah.
It's really fun.
Yeah. So anyways, I'm talking today about Are We Web Yet? What's the state of like backend frameworks and stuff in Rust? So I'm gonna break things down a little bit into basically like 3 domains of things that you're doing in web. We have it like the smallest level. We have microservices. These are like really tiny services that are self-contained, and then you try to compose a bunch of these little things together and make something bigger out of them. And that's cool because you can use HTTP, which is like technology agnostic. So you can have ones that are written in Python, written in Ruby, and written in Rust, whatever. I'm gonna try shutting the door.
Yeah, shut the door.
Yeah. Oh, that's so much better. Then like one step up from that, and this is what I was actually interested in writing in Rust, is APIs. And so you've got this like more complicated thing, but it's like almost completely back-end. So you're just doing stuff in like JSON or whatever. You're talking to a database, things like that. You don't have to worry about like front-end stuff. You don't have to worry about HTML templating, serving up JavaScript, whatever. So this is a little bit bigger, but still pretty back-end focused. And then you've got full web applications where you need to have more things like form processing. You need to have a lot of like input validators, things like that, cookies, all these things that would be implemented in like middleware or something like that. And so, kind of like think about it in terms of these like three different kinds of apps that you could build in Rust, and we're gonna see what the frameworks are and what they would be suited for building. There are a couple of challenges to doing web in Rust. One of them is that there's way too many framework choices. There's seriously like 50 of them out there. I couldn't even go through all of them. It's just ridiculous. So I tried to pick like the top couple ones that seemed to be the most well-maintained, that had a lot of usage and so on. So it's like kind of overwhelming if you're just trying to get into this and like I want to build something web. Another one is that database libraries mostly don't support async that well yet. Most web frameworks are designed around futures, and those are asynchronous by nature, but most database frameworks don't work with futures directly. There are a few that do, but they are generally much less mature, and they're really hard to use. They don't support connection pooling and things like that very well. So like Postgres is the one that I was interested in. And there's a Tokyo Postgres library, but it's kind of sucky, and it doesn't work with any of the major connection pooling libraries. There are also a surprising lack of blog posts and things like that about people that are building real production web applications in Rust. There's lots of, hey, I wrote this little like hello world sample in framework X, but that's not really something you can take away and say, I'm gonna actually go use this at my job or something like that. It's just this really tiny, like contrived example, basically. And I guess kind of going into that, this lack of adoption means that there's not a lot of consensus on like best practices. So it's like, how do I set up my database pooling, or you were showing me something, like how do you organize your project into like models and handlers and something else. There's like I just learned that a few minutes ago, like that's how you're supposed to do things with Actix, because there's like no documentation on this. There's no like
supposed to.
Yeah, right, exactly. There's no consensus about it.
Yeah. There's like nothing at all.
Yeah.
That was just the way that I found that was like the most logical.
Yeah.
I mean, I was used to Rails actually.
Where it's like super structured, right?
Well, yeah. So initially, I made a controller section and a model section and a view section.
Yeah, right. MVC, yeah.
And then, then I realized that the files did not logically represent what was going on. So then I kind of like thought about it, and then I think I actually saw someone else's app. They had like a handlers folder. It's like, that makes so much more sense.
Mm-hmm. Yeah, that makes sense. Yeah.
So there's just no consensus.
Yeah, there's no consensus about stuff, and that kind of sucks, because it's like, when you're going into something for the first time, and you're like, okay, like how am I supposed to do this? So with like the kind of like challenges and everything in mind, with all the like being that there's like 50 some frameworks or whatever, I end up coming up with a short list of like these are the ones that I think are actually usable. The first one is, I know this isn't really a framework, but you can just use raw Hyper. Hyper is what the vast majority of the frameworks are actually built on top of, because it's like the correct, fast HTTP implementation in Rust. You can actually build a pretty significant size app using raw Hyper, and I'll get into like the advantages and disadvantages of that later. Then there is Rocket, which is very well known, has a really pretty marketing site, fantastic documentation, but we'll talk about that later. Then there's Warp, which is a very, very small micro framework. I wouldn't really compare it to Flask in Python, it's like even smaller than that. And then there is Tower Web, which has a little bit more features than Warp. One of the Warp co-authors is actually the author of Tower Web. And then finally we have Actix. So the criteria that I used to come up with this was, and that we're going to use to evaluate the different frameworks, is the state of their maintenance. Like, do they have like recent commits on GitHub? Are there multiple contributors? Are people actually using this? How easy is it to use? A lot of them are not very easy to use. They have like no documentation. And performance, of course. That's kind of obvious. You want something that's performant. And the feature set. Depending on what kind of application you're building, you will need certain features, whereas you might not with other ones like, say, microservice. Okay, so let's dive right in and talk about Hyper. So there are a couple of good things about just using raw Hyper. It's, like I said, the foundation of basically all the other good frameworks. I think every single framework that I could reasonably recommend was built on top of Hyper. It's very well maintained. It is the de facto HTTP implementation in Rust. It is blazing fast, and it is 100% futures based, which means that it'll work out of the box with any kind of async setup using Tokyo, which is the main futures executing library. But there are a couple of bad things about Hyper. First, like I said, it's not really a framework, so expect to write a whole ton of boilerplate. We were talking earlier about how I had a project with like 40-something force unwraps in it. That was my Hyper project because I needed to use regexes for matching the routes, and then I needed to go and unpack all of the things that were inside, like the different path components that could exist and stuff like that. And so I had logic to ensure that a force unwrap wasn't going to go wrong, but it can make for some really ugly code, and I've got like something this long for parsing all the requests. So expect to write a lot of boilerplate. There's also a moderately steep learning curve to it. You're dealing with a relatively low HTTP framework, so that's what you get. And then I put this both in good and bad. It's also futures-based, which are its own learning curve in and of itself. Then we come to Rocket. Rocket is got a fantastically designed marketing website. It has amazing documentation. It's like the best in class by a wide margin. They have like really detailed documentation on how everything in the framework works. It's also actually pretty actively maintained. And it's almost as easy as using a modern Python framework. I come from Python, you do a lot of Ruby. They're very similar in that they're very, they have a lot of very well-maintained web frameworks. Well, in Ruby, I guess there's only one web framework, really, but yeah, there's the Rails. That's what you're supposed to use. In Python, there are a number like Django, and they're all very easy to use. Like adding new view routes or something like that, it's just like a few lines of code at the most. It's really simple. And Rocket nails that because you can have these like attribute style, it's like a method decorator or something, and you can say like this is a get route for /A/B or something, and it works great. And as a result of all this, the resulting code is really concise. I put a screenshot in a Telegram group a while ago. It was like I implemented this whole API in like 40 lines of code. It's like amazingly concise code. But there are a few really bad things about it. I'm not sure if this is a bad thing or not entirely. It can kind of go either way, but it's very highly controlled by a single person, it seems. Is kind of like the Guido of Python. This is like the guy who does Rocket, like the benevolent dictator that says this is how the project goes, which can be a good thing or a bad thing. This guy doesn't seem quite as smart as Guido, so I'm saying it's a bad thing. It's sorry. It's built on some really outdated dependencies, most notably Hyper, and I think that this is responsible for some of its weird problems and performance issues.
So you mean the current Hyper is it could use the
It could, yeah, it's not using the current Hyper, and I'm not sure why. I think like it was built around this one version, and a lot of breaking changes or whatever happened since then. It hasn't been updated yet. It's been like there's actually an active GitHub issue for it. Like it's really weird. It's like really actively maintained. Like it's like, oh, this is getting pushed to the 0.4 release. Oh, this is getting pushed to the 0.5 release. Like it's actually like really active on GitHub, and like he actually even says like this is a problem, but it's not happened yet. So I don't know why.
yeah.
That's a very bizarre situation. Performance was anything but rocket-like, to say the least. It had absolutely terrible stability under load. Just running WRK, a simple command line load tester, it had like socket errors all over the place, and its overall throughput was really, really terrible. I'm going to show you some graphs at the end of the presentation of the benchmarks. It was terrible. So if you're considering making something that you just want to be really easy to use and stuff, just go write it in Python or Rails or something like that. It's actually going to perform better than Rocket, at least right now. So I really hope that they fix this stuff, because it looks like it could be a really, really awesome framework. It's the best as far as like everything's so well thought out. It's like someone like actually looked at all the like decades of experience building web app frameworks in other languages like Python and Ruby, and then I don't know, whatever. I actually think the big problem is that he used a thread pool instead of doing everything futures based. It's actually like just like raw thread worker threads and stuff like that, and that really kills throughput. And apparently it also.
So is it using Hyper before it implemented features?
That's actually a good question. I'm not sure exactly how he ended up doing it. Like it's almost like there's like worker threads that their whole job is to like loop through futures and wait on them or something like that. I don't know. Like I don't understand how the performance can be that terrible otherwise. Or maybe it's just a really maybe it's just a bug in like the really old version of Hyper. I don't know.
Well, someone mentioned that, right? There was a keep alive bug in the old version of Hyper or something. Like it would.
Yeah, I saw that. Yeah.
It would say it was a keep alive connection and then just drop it.
Yeah.
After that.
Yeah. So I mean, it could be like that was like.
Yeah, if you
really
do,
old version.
it could be like your tests are like, because it's just one machine constantly reconnecting. It might just hit that bug and then cause a lot of problems.
Yeah. I mean, I even had like when in my connection test script, then it even would like you can configure like how many like threads with their own keep alive connection it'll keep reusing. So it could actually be that keep alive bug. Yeah, I don't know. Whatever the case, it's not ready right now. Okay, so let's talk about any questions or anything like that so far. Interactive presentation. Just let me talk. Cool. Okay, so I guess next we'll talk about Warp. There are a couple of good things about Warp. It's fast and it's really small. I think that is the end of my list. That is the end of my list. It is fast and it's really small. So if you're writing something like a microservice or something, Warp actually performs really well. It actually will perform better than Actix at a very, it's a very small workload. But you're not going to get a whole lot of batteries included with Warp. It was actually basically designed, like the blog post introducing it was basically saying, I'm building this framework to explore this concept of everything being a filter. He thought this was like this really elegant idea, like he made this filter trait, and like everything is implemented using this filter trait, like routes, like query string argument parsing, paths, things like that. It's all implemented using this trait that he made called filter. And it's like this, it's like someone, slapping a calculus proof on your desk, and you're like, huh, that's kind of cool. I'm gonna go meditate on that for a while. So like, I don't know, okay, I don't know. It works, but it's a little bit weird. Because of this, it has a fairly steep learning curve, in my opinion. And that was basically my evaluation of Warp.
Oh, what's it built on? Is it built on Hyper also?
Yeah, it's built on Hyper. Yeah, it's built on Hyper.
All built on Hyper.
Yeah, everything that I actually made in this presentation was built on Hyper.
Yeah.
And as a result, the performance of most of them is pretty good. They're going to be within a good margin of each other. I'll show you at the end some benchmarks. Next one, Tower. This one was written by one of the co-authors of Warp. This one is pretty cool because it supports, like Rocket does, those like macro attribute based route definitions. So you can say like hash open brackets and like this is a get route for /users/whatever. And it does like, interpolation of parameters and things like that in the URL. So that's pretty cool. So it's really good from a developer user friendliness standpoint in that regard. It also had pretty reasonable handling of shared app state. That's one of the problems that a lot of Rust frameworks have. Like, how do you like pass your database pool on through things like that? This did a reasonably good job of it. It also had support for handlebars templating built in. So, like, if you wanted to build a really small app and you wanted to, put a little, template-based thing in there and generate some HTML, then this will actually do that for you. But there are a couple of bad things about it as well. It has this nice, attribute-based, route with parameter interpolation and stuff like that, but it doesn't support floating point numbers. There's no way to when you want to do stuff in get stuff from the query string, you literally get the query string, and it's like good luck parsing that. So it works great if you have simple string or integer based path components that you're using, but it doesn't really work beyond that. And I looked into it and it was like, okay, they've got this complicated logic or whatever, and it doesn't work because of some trait or something. It doesn't work with floating point numbers, so it's like, okay, whatever. So I ended up just using strings and using string.parse. But you can't. But the problem is then you can't say okay, it got to this handler. Now I have to add error checking for the inputs in my handler, as opposed to the framework catching that up front, which is what you would ideally be doing. It's it's basically the same thing. And then it also requires some weird macro stuff, wrapping you define your application as a struct, but you have to wrap it with this implement web macro that they provide, and then it generates the code to all this boilerplate code or something like that there. And so you have to wrap it with that, which means that your IDE goes wonky because it can't figure out all the types and stuff of everything that's inside this giant macro. And then finally, we get to Actix. Actix has actually pretty good documentation. It's not quite as good as Rocket, but it's actually pretty good. It's still async, but it allows you to bring in sync code really easily. I was really impressed by that. You mess around with the database stuff in Actix and you see the sync arbiter that you wrap stuff in. So you can say okay, I want 20 of this thing, and it's going to call this function 20 times and spin up 20 different threads that you can pass messages to. So you can send a message to my database executor object that I know I have. It just takes care of keeping those threads alive and stuff. And so you can just send a message to this saying, hey, I want to do this thing, and then it'll write back with the result when it's done. So it provides a really clean way to do synchronous stuff. Like the database libraries, most of them don't support async properly. So this actually provides a really elegant solution for that. And since you can only have your database pools can be a finite size, so it actually maps pretty well for doing things like that. It's probably about as close to raw hyper performance as any framework's going to get anytime soon. And I will again show some benchmarks to back that up a little bit later. And also as a plus, unlike everything else, it's actually really close to a 1.0 release. It's been actively developed for a very long time. They're currently at 0.7 something, and they're in the alpha phase, is it, for 1.0?
Yeah, it's like 1.0 alpha 6 or something.
Okay, yeah. So they're almost there.
Yeah, the problem is documentation is good, but it's for 0.7 most of it.
Right. So I hope that they can update that.
Right. I asked the guys, and they're just well, you just have to look at the generated docs right now or the examples. They actually did update their examples, which is really nice.
Oh, okay.
So all the examples are either on 0.4 or 1.04 alpha or 1.06 alpha. So it's actually pretty. That's been better than a lot of the other stuff. So
yeah. And they seem to have an active Gitter chat, I guess, so
yeah,
that's good.
That and Diesel have really active chats, so
okay.
I just go on there and ask questions all the time.
Nice. Yeah. So I just add community to the list of good things. It's also going to be approximately 3 to 8 times faster than the most carefully written Python for non-trivial tasks. Python is what has like been a key part of my job for like the last over 10 years. So I can write some pretty fast Python, and this is many times faster. So if you need something that's performant, then this will be up to the task.
Is it faster if it's carefully written? Or?
Say again? Is the Python faster?
Is the Rust okay?
Oh, the Rust code? I don't know, actually. There's no best practices on it. What's carefully written mean? You know? That's a good question. I do not know if the Rust is...
I wonder how that will measured.
I was talking about the Python being carefully written, not the Rust.
But you're comparing it to Rust. But
Right.
What kind of Rust?
That's a good question. I thought it was pretty well optimized code, and I did all my tests in release mode, obviously. So the thing with Rust is that they generally try to make idiomatic code have zero cost abstractions. So if you're using things like iterators and stuff, then it's going to be zero cost. If you're using generics, it's going to be zero cost. Futures, the most common thing in this whole stack, it's all zero cost. The async stuff is zero cost. So I think I did a pretty good job of verifying that the Rust code is very carefully written. Yeah. Good question.
It's easier to write bad Python code than
It's much easier to write bad Python code than it is to write bad Rust code from a performance standpoint.
compiler just
Right.
things at you.
Right. Well, in the case of Python too, then like async is fairly new to Python as well. So like when I say like very carefully written, optimized Python code, then I mean not just using any old framework, not just like pulling out Flask or something like that, throwing a database backend and hoping that it works. For my tests, then I actually used AIO HTTP, which is an asynchronous HTTP library for Python, as well as a new async database driver for Postgres, and that actually like outperforms the de facto one, PsychoPG2, which is written in C. That actually outperforms that library by like 3 times in typical tests. So that's about as fast as you're going to get with Python. It's obviously it's a much bigger multiplier if you're just using like Flask with the PsychoPG2 or something like that. So there are some bad things about ActiveWeb though. One of them is that it's much more verbose than I'd like. You have to write a lot of boilerplate. What they did was they tried to take the actor model from Erlang and port it to Rust, and I think I'm actually going to talk about this again. Yeah. So taking a paradigm that was designed for one language and porting it to another language seems a little bit like an odd choice to me. But I have to say they did a really fantastic job of it. And they also made it like basically zero cost, as you'll see in the benchmarks. It's like that I really give these guys props because they took a model from that was designed around one programming language and ported it to another, and it performs really well, and it only has as much boilerplate as it does. Again, it seems like no one uses stuff in like serious production. Like databases are somewhat of an afterthought. They do have a database page on their website, but they're telling you to do things the wrong way. I'm actually probably gonna go and like write a pull request for this because I'm like so mad by it. Like if you write the database code the way that they told you to, then unless you throw in your own connection pooling and stuff like that, the way that they tell you to do it, if like your database server dies or if it like kills your connection off or something like that, then that like thread, that executor will no longer work, period. What? You'll just get a 500 server error and nothing, you'll have no idea what's going wrong. So it's...
I haven't thought about
yeah, right, like, seriously, like, yeah, I don't know. Feels like, like best practices and stuff like that. Just have it. That no one's really put thought into this. It's like it's not being used in production or something. Mm-hmm. So, but I think you were using R2D2. So if you use an R2D2 pool, clone that, put that in there. That pool, when you clone it, it doesn't actually like copy the data structure or anything like that. It just copies the state of things, and so that's actually completely safe to share across threads, and it's not like you're like creating another pool of 20 connections or something like that. So that's the way that you should do it, but their documentation is wrong, and that kind of annoyed me. So some conclusions from all this. Most frameworks are pretty immature, and they don't really seem like anyone's actually using them in production. It's not that they're not production ready, it's just that no one's actually using them in production, so they haven't solved the right problems in my mind. Most of them are not terrible performance-wise, so it's not like they're don't ever use this, but it's like they haven't really put the thought into how are you going to use this when you're building out a real application. Not enough attention is paid at all to developer ergonomics. Like, why don't all of them use the like attribute style of saying this is where this path is, this is the route for this path, you know, call this function. Like, why aren't you using that? Rust is definitely a viable choice for APIs and microservices, going back to like the 3 domains at the beginning, especially if you really need high performance. But be prepared to put in a whole lot of work if you're building like a large complex web application. Like your routing logic and stuff is going to be kind of spaghetti at this point. Futures and async will probably be the thing that trips you up, but Actix makes it pretty reasonable to work with at the least. So things like I need to do some synchronous code. I don't want to put in the work, or I can't reasonably put in the work to like box this up into a future or something without just like spawning a thread. Actix will do a pretty good job of that for you. Async database drivers are still immature. There is a lot of work being done actually on the Postgres version right now, so I'm hopeful that that will be a thing for Postgres, using the raw Postgres driver soon. Also, the guy who wrote the Postgres driver is the same one who wrote R2D2, the most popular connection pooling thing out there. So I have hope that R2D2 will get async database support for its pooling. It does not have it right now, though. There's another library called BB8, because what do you call the follow-up to R2D2? Of course, let's pick another Star Wars drive. Let's pick C-3PO. But it's terrible. Don't use it. It's impossible to use. Even among the frameworks that I disliked, most niceties like input parsing are so fast that they're basically free. It's like a testament to Rust's commitment to zero cost abstractions. And of course, things like parsing are going to be very efficient anyways. Most people are using Serde, which is extremely performant already. And so if you're doing things like complex parsing of paths or things like that, then the frameworks do a really, really good job of that so far. And if you need really high performance, then Rust can definitely deliver for you. And with that, I have some benchmarks. I can like pass around my laptop or something if you guys want, but on the left side, then I've got a simple Hello World demo. And then, there we go. On the left side, I've got a simple Hello World demo that basically does nothing, just like spits out Hello World or something. And then on the right side, then I've got a really heavy PostGIS database query. That's a geospatial database, so I'm doing geospatial queries with it. So, in other words, this one is going to be basically bounded by the framework's limitations, and this one is going to be more or less bounded by the database. So how well does it work with this kind of thing in a really high-load environment? So on the far left side of both of these graphs, I've got Rocket. These measurements are in connections per second, by the way, and I've got my methodology for measuring this. So Rocket is really, really terrible. It only gets a bit over 500 requests per second, even under like a basic Hello World.
That's the Hello World.
Yes. It's terrible.
It's slower than the IOACP.
Yes.
It's slower than a Python.
Yes, it's slower than Python. It's actually slower than even like Flask or something like that. I think Flask can do like 1,000 or something a second. More performant ones like Bottle or Falcon
really
can do like
second?
3,000. Yeah.
I knew Rocket was bad. I didn't know it was that bad.
Yeah,
like how can it's built on Hyper, so how can it be that bad?
That's what I said. They've either got a critically messed up version of it. Like there's this terrible bug in it, or I think they still be doing something bad with like how they're doing thread pooling or something like that. Because that can really kill your performance. So I don't know. Then you've got AIO HTTP, which actually will break 10,000 a second, which is pretty freaking awesome for Hello World. And it's actually not terrible as well on even like a. Go ahead, sorry.
Sorry, quick question. Was there a UV loop, or what was the loop used for the AIO HTTP?
Using G-Unicorn has a they actually have a HTTP what's it called?
So like Python web frameworks have the.
They have AIO HTTP has a G-Unicorn built into it.
Okay. Because I know there's like a few for Python. There's like Sonic actually, right? I think Sonic is pretty fast. It's like Sonic with an A.
I've not used that one
There's
before
UV
actually.
loop.
Yeah,
I know
I've
it's
used
pretty
UV.
fast.
Yeah, I've used UV before. I think that's C based or something.
Mm.
A lot of Node stuff uses UV too. I think under the hood, like it's all like this C library. Anyways, so yeah, you won't get these kinds of numbers out of Python typically. Typically, you're going to see like maybe half that or something. But if you're using the latest async Postgres database drivers, which are pretty new, they only work in like Python 3.6 and higher, then you can get some actually pretty good performance out of it. Then next up we have Tower, which then you can see like the top. These are the real cream of the crop hyper frameworks, and they all are pretty similar. This is a logarithmic scale, by the way. If I put it on a linear scale, then like these would just like go way off the chart, and these like you couldn't see them. So those are pushing like well over 50,000 requests a second on Hello World. Actix actually gets almost 80,000 requests a second. It's absurd. And then it's really like margin of error differences in terms of a loaded database test. So honestly, any of these, you can use them for production load, but for all that Actix gives you, clearly the performance doesn't really come at any cost to you. Actix technically did just slightly slower on the database loaded test, but your real world workloads are probably going to be somewhere in between here and here. Like this is a really heavy database query, and this is like all like simple Rust compute, like just doing strings and stuff. So your real world load is probably going to be somewhere in between there, and Actix would shine into that situation.
Yeah, I was confused at first because 500 is almost half as much as 80,000.
Right, exactly. It's a logarithmic scale, otherwise it just wasn't readable. Yep. Cool. Any questions? Stuff to talk about?
So what framework are you the most optimistic about? Do you think in 6 months' time Rocket will be fast enough and the most usable?
I'm a little bit pessimistic about Rocket. Just based on their past history, like you can see like threads from a couple of years ago about Rocket's performance.
Okay, so maybe ActiveX would become more usable, and then that'll be the
ActiveX, go back to the 90s.
Why did ActiveX?
I have no idea.
It's a living in Korea, you know.
Yes,
exactly. That was legislated, right?
Did you
Yes,
Frank
yes,
ActiveX?
yes. No, yeah, I think Actix is the most actively developed, and it has the brightest prospects for the future.
Yeah, I mean it's different. So I mean, no language really has an actor model unless you work with Erlang.
Yeah.
Or I don't know really what else uses it. I think Pony. Pony is like the other one that's like actually based on that. That's today we've been throwing out these random names.
Did you just make that up?
It's like, is Andrew totally lying about Carbon, Crystal, and Pony?
Yeah, right.
I'm pretty sure it's called Pony. They had like something like this, like an actor model, and it was supposed to. It's just hacker news, man. It's just all these good front page there.
Yes.
But what's the model, the most performant model? Is it just like
It's just nice to
It's
know.
not necessarily good or bad. Like it's not.
It's just a different way of doing it.
Yeah.
It's like so, for example, like creating a user. So if you do it like the Rails way, it's like you would create a controller. So the logic goes to the controller talks to the ORM and saves it.
Yep.
But in ActiveX or no,
Spreading.
in ActiveWeb, you would so you make a handler, which is so you basically like if you want to create a user, you create a
create user message that goes to like your ORM handler or whatever.
Yeah, so you create a message and then you implement handler on that message, and then whenever something comes in, it just goes to that handler.
But
And then you have
it's-
like a bunch of thread pool or whatever, like
Yeah.
4 connections, so then it just goes to one of the handlers and you're done.
It's more of a way of like a convenient way to structure a program that handles
Correct.
synchronous
Correct.
code well, right?
Correct.
And then it's got some reliability.
It has async as well. Like the only reason I mentioned that was because that's the unique thing I feel it brings. Because like everything is futures based. Like all these are futures based.
And maybe it is a good model for a web framework, an actor model. I don't know.
I don't know. I mean, it's just another concurrency model, and it actually I don't like the amount of boilerplate that it generates, but it actually works really well, and it makes the reasoning about it a lot easier. Like it's easier to write code that you don't have to worry about this junking. Like I can't make my database thing async, or I can't make process X async, or like I need to run this really expensive computation. You know, that's a thing too. You're not supposed to do like heavy computation inside a future. That should be dispatched on another thread or something. So you can make another sync executor that will do that for you, and it makes it really easy to structure your code without having to muck around in all the details.
So have they like implemented some kind of actor library in Rust?
Yeah, Actix is the thing that Actix Web is built on, and Actix is the actor model implementation. And it's all built on top of Tokyo, by the way. Tokyo is the futures executor model. So MIO, I think, is the base level that everything builds on top of, and then Tokyo is the most popular futures runtime library. I think there is technically another one or two, but Tokyo is the one that all the development attention goes to, it seems. And then, so you've got at the base layer, you have MIO, then you have raw Tokyo, and then you have Actix, which is the actor model implementation on top of Tokyo, and then finally you have Actix Web. And the thing that impressed me again about this is that they were able to provide this structure for you at no cost.
Right.
That's pretty impressive.
So what do they need to improve usability? Do they like attributes?
Yeah, but that's the biggest thing I think. Yeah, that's the biggest thing.
Routes are probably the weakest part right now.
Yeah.
It's like you have to create a server and then you have to nest the stuff underneath. And it used to be kind of
Server
decent.
setup's also another kind of pain point, but it's
Yeah.
not terrible. It's not as terrible as making this giant tree of routes.
Right. Right now it's like super nested to the point where I don't indent by 4 spaces like normal. I indent by 2 spaces. And I actually, only for that section, I turn off cargo format.
Okay.
It's because otherwise it'll just be too indented.
Nice.
And that's when you know you have a problem.
And you have this like tiny, like, it's not even that big. Like you've got like
No, it's not.
a dozen
Like, I
routes
just-
or something. Like
No, it's just I seriously have like 3 routes, and the reason is that you have the app, and then it's namespace under like
Right, so-
I have a
right.
namespace under like an index, and then a users, and then the user routes underneath the user's namespace. But it's like for each one, for some reason, you have to call 2 things. So basically, for any of these frameworks, they need a DSL. It needs to be like
Yes.
Ruby or anything where it's just either you have one really nice routes file, or like Flask or whatever.
Yeah,
you
where
just-
they've got decorators.
You tag each function, and then you don't have to worry about it.
Yep.
And then I would also like to see like an ORM DSL as well, because at least with Diesel. And
So I was
Actix,
gonna say, give us an update on Diesel. I haven't touched it, but it looks interesting.
it's really good. It's just for each one I have to write the SQL manually, and it's just kind of annoying. It's like
Interesting.
I just miss where I
So,
just have like a migration, and then I write the Ruby. And
Right,
then
right.
that goes to SQLite or
Right.
Postgres or MySQL.
Right.
Now if I change to Postgres from SQLite, I'm gonna have to rewrite my custom migrations.
So okay? So is the problem migrations?
It's not migrations. It's just like a
agnostic.
Huh?
It's not not database agnostic.
no, not yet because there's no DSL. You just
I
write
thought
you just write the SQL.
Diesel like. So okay, so you can't just use. I know there's like Diesel Postgres, Diesel MySQL, whatever, right?
Mhm.
So you have to write. So you can't actually switch out backends interchangeably.
You can. You just have to update the SQL.
So so there's no SQL generation built in. Is the problem?
To my knowledge, I don't think there is.
That's
So
interesting.
it's not that big of a deal. It's like
Yeah.
you can do it. It's like actually SQL's a very nice language in my opinion, but it's not like Rails where it's just like you generate a migration and it's like very short.
Right. Yeah.
And then it maps to something, so you can always
Yeah.
change your database whenever you want
Right.
later, so long as it's one of the supported databases.
Yeah.
So what it does for you is serialization. Is that what it does? Like it's got some pre-build stage that generates the structures and stuff.
Yeah, so it generates a schema, and then you can pull it into Rust. So you can just include the schema file, and then by default it puts it in your source folder. So it's really nice.
Yeah.
So that's what Diesel does.
For my so I've not explored it extensively, so don't let me be
Interesting.
like the guru or anything.
Yeah,
I've just used it like a little
I'm
bit.
just curious because I haven't touched it at all. So yeah.
But it was pretty easy to set up Actix Web async routes with Diesel.
Yeah.
So I have like an app fully working where I can create and show users in a SQLite database. It's all async
Right.
with the actor model handlers.
Right. Yeah.
So it only took me 2 weeks.
Yeah. Yeah.
Do any of them have like plugin support? And what about like SSL or like Let's Encrypt or?
Yeah, so I don't think any of them support Let's Encrypt out of the box. Hyper does all the HTTP stuff, so I mean, it can do TLS and all that. It can do certs. I mean, realistically, you'd probably want to put like HA proxy or Nginx or something in front of it, but like, I'm really impressed that most of them will actually hold up to like serious hammering. So you can actually deploy this as just, here, I'm going to throw a binary on my server and bam. You could do that. I would still probably put something in front of it just to handle like, upgrades you roll over from one to the other and so on. But
Or like Let's
you
Encrypt.
can do it. Yeah.
Let's Encrypt. I mean, I'll just use like Docker because then you can have two services. You have a local container. Huh?
So you can have a service specifically for Let's Encrypt or something? Or what do you
Yeah,
say?
well, because of Caddy. Because Caddy is like Nginx, but like a million times easier to use, and it does Let's Encrypt out of the box. You don't have to do anything. You just deploy it on the server, you turn it on, and then it automatically pings Let's Encrypt and gets you your certificates.
Okay.
It's literally zero cost.
That's cool.
Except if you test it locally, you have to make sure to shut it off because you will get rate limited very fast. It needs to make for Let's Encrypt. It needs to make sure that the IP matches where it's requesting or where it's coming from.
Okay. Yeah.
So I've burned myself where it's like, I have to wait like 24 hours before I can deploy something because I can't get the certificates for it.
Well, you could just, I mean, there's other ways to do that too. There's like CertBot or something that will automatically renew and works with Nginx and stuff. So, I mean, there's options to do Let's Encrypt in front of this without any issue.
It's just like, it's more so also the config files. So even Nginx is nicer than Apache. And then Caddy is just like really nice, simple directive files. It's so like elegant and beautiful.
Yeah.
There's like literally zero configuration. It's just like, point it to my local Docker thing hosting the Rust thing, and then that's it. And I'm pretty sure the only production case that I know of for Actix is that someone there were like
I
hosting
saw
a
it. There was
concert.
a music event, something.
Yeah, I might have posted it in our group chat.
Yeah, I think you did.
I think they put something like Caddy in front of it.
Yeah.
But I don't think they ever open source the code.
Yeah.
But yeah.
Figures. I mean, it's proprietary event, so.